Okay, welcome everyone to the breakout session of the Open Science Graphs for Fair Data Interest Group. Really good to see you here today. I want to start with a brief introduction. So I'm Helena, I'm one of the co-chairs of the interest group, and I will tell you a little bit about the group and also provide a quick overview of the work of the Scholix working group. And then you'll hear from some of the other co-chairs. Andrea will provide an overview of the work that's done by one of the other working groups. We'll hear from Amir, also co-chair of the group, about the Research Link Australia graph. And my colleague Mike will present on DataCite PIT graph. Our co-chair Paolo will give you an overview of Open Science Graph use cases. And then our fifth co-chair, Anita, will share a proposal we have for an internship project, and then we'll have some time for discussion. If you have any questions at any point during the session, please feel free to put them in the chat. We're happy to spend time on discussion, not just at the end, but also during the session, because obviously this is an opportunity for us to get your input and hear from you as well. So yeah, feel free to do that and let us know if you have comments or questions. So a little bit about the Open Science Graphs for Fair Data Interest Group. I think it's been around for a couple of years, and what it intends to do is bring together the discussions taking place in the Scholix working group and the RDA working group on scientific knowledge graphs, so that we have a place to have sort of those overarching discussions and coordinate. We currently have quarterly meetings. You should be receiving those invites if you're a group member. If not, you can go to the RDA website and add yourself to the group. So then you start getting updates and invites to the meetings. Just to say that there's one scheduled for next week, but because we're already having this session now, I'm planning to move that. There's been a change to the group functionality, so I'm not actually able to move the calendar invite. But I will be sending a message to the whole group about this. But yeah, for those of you that have it in the calendar, just to say that we'll be moving that to next month because we're already meeting today. Yeah, then very briefly about Scholix. Scholix stands for Scholarly Link Exchange, and it's a framework that was developed by the RDAWDS Scholix Working Group, which has been around for a very long time. The group is now in maintenance mode, and that's also one of the reasons why the conversations about Scholix are taking place under the umbrella of this interest group. If you've been participating in RDA meetings for a while, then I'm sure you've come across it. But for those of you who are new to it, I did want to provide a brief overview. I think it's very important to say that it's not a specific organization or a specific service, but it's a framework for standardizing the exchange of scholarly link information between scholarly infrastructure providers. Initially with a focus on articles and data sets, but more recently, we've expanded this to software and looked more generally at how do we exchange information about these connections. The reason the Scholix Working Group was founded and the framework was established because there is great value in linking research data with the literature. But in many cases, these links were not being established when the group started because the sources were disconnected and there was a heterogeneity of practices. And therefore, it wasn't easy to aggregate information about connections between research data and articles. And so using the framework that describes how links can be established and exchanged. There's a framework to contribute information to hubs. And this is already quite an old visual, but I think it still explains well what the thinking was behind the framework. Initially, information was just exchanged between two parties. So a publisher would work with one repository to exchange information about the links between an article and a data set. But because we wanted to make that available to the broader community and have a standardized way of exchanging that, Scholix provides a standard set of guidelines for exposing and consuming links, and these can be contributed to different hubs. For example, as a publisher, you can put information in the metadata in a way that follows the Scholix framework, and then send it to Crossref, and then Crossref makes it available to the community. And the same goes for DataCite. Repositories working with DataCite can put this information in the metadata in a way that's in line with the Scholix framework, and then DataCite makes it available to the broader community. And that way, information about the links between data sets and articles is aggregated and made available. And this is sort of the framework that we use, the link information package, where we describe a source object and a target object. I mean, this can be in both directions, so from the side of the article and from the side of the data set, to describe these connections. Yeah, before I hand it over to Andrea, just to say that information about links between articles and data sets were really a starting point. And now that a lot of work on that has been done, the time is right to not only think about those two entities, but think about the many entities within the research ecosystem. And that's also where then the open science graphs and the scholarly knowledge graphs come in, because those provide a way to link all the different entities together. And so with that, I'll let Andrea present some of the work done by the Scholarly Knowledge Graphs Working Group.
Thank you, Elena. So, hi, everybody. So I'll try to do a bit of debriefing on what we have done in this Scholarly Knowledge Graph Interoperability Framework Working Group. Next slide, please. So a few persons here attending today are familiar with the working group, but I think others, for others, could be the first time that they come across our activity. So I'll use the same kind of slides, so bear with me for a few minutes. The working group on SKGIF has been incubated within this very interest group on open science graphs for fair data. And at the beginning, we were organized as task forces. So this was back in summer 2022. And we have been officially endorsed as a working group last year in summer. And the life cycle of our activities is going to wrap up in December this year, so it's 18 months total. The chairs that are leading, trying to organize the activities, it's me, Silvia Peroni from Open Citations, Jason Portnoy from OpenAlex, and Sahar Badati from the Institute of Applied Informatics. I can't remember exactly the translation into English from German. And there are other people from CNR-ISTI, my institute, that are actually lingering around our activity pretty much all the time. Miriam and Paolo as well. And next slide, please. So in a nutshell, what is this general spirit behind our work is that there are a number of initiatives that are trying to reconstruct the scientific track record, and it's kind of a crowded space because we are many, and we try to aggregate data, metadata about scientific products from many places, and if we want to exchange information, some of us are providing data for free, so the wealth of information is open for everybody in principle. Next slide, please. Our best shot to exchange information from one source to another is to establish point-to-point mappings, collaborations, mapping data back and forth. And this is what we have been doing so far in many cases. And that's unfortunate because it takes a lot of time to reinvent the wheel, and it leads to unnecessary duplication of effort. Next slide, please. So it would be better to come up with the kind of agreed upon solution to share at least a core wealth of information that's kind of factorized across all of us joining this space. And this is what led to the main idea of the SKGIF. Next slide, please. So the standard application would be that every scholarly knowledge graph out there has its own internal model, but when it comes down to interpret with others and exchange, we could map towards an external model that's just done for means of interoperability, so that everyone speaks the same language and can be understood by the others. Then we also had this idea about the catalog, where this is something we need yet to discuss, but in general, that would be basically at least advertising for all of us that are providing data, scholarly data, openly, and listing the general properties and enhancement and application that's supported by the single graph. Next slide, please. So the kind of methodology and organization that we gave ourselves is this one. So we had compartmentalized actions. One was on defining the core model. Another one on establishing what could be a viable exchange format for moving metadata back and forth. Protocols, and the last one, as I was saying before, on these profiles manifesto describing scholarly knowledge graphs. Next, please. And this is the current status. So in relation to the core information model, we went through a first iteration, and we are now on an never-ending ongoing maintenance and extension. About the data exchange format, we are sticking with JSON for the time being, and we are also evaluating other possibilities. As we speak, I put in the next agenda an item about schema.org. We need to discuss. We had some proposal from Daniel Garijo recently, and that's something we need to discuss and see if that could be feasible. In terms of access protocols comments, we defined a simple API resolver. We don't have we didn't came up with a full-fledged API. That's a huge task. I don't know if there will be enough bandwidth within the working group to come up with a solution for querying and filtering data. So at the moment, we are sticking with this very, very simple API resolver. I'll describe that afterwards. And about scholarly knowledge graph manifesto and profiles catalog, it's something that I think I hope we will find time to discuss in the last trimester this year. Next, please. So we have a website. I'm sorry I didn't put the link in the slide. Apologies for that. I'll share that in the chat. here it is a website on Reader Docs. There's a GitHub repository behind that. Anyone in principle can collaborate. So requests or to the replies, and it describes, like you described before, core model, format, exchange.
Is it my connection or is Andrea breaking up?
No, it's Andrea. Andrea disappeared.
Yeah, not just you.
I think you're back now, Andrea.
Yeah. Okay.
Yeah, we
Okay,
lost
yeah.
you. We lost you.
Yeah, we lost
okay,
you
I
for
was
a
breaking.
second.
Sorry.
Yeah.
What was the last thing I said that you heard?
It was like a drowning noise.
Yeah, it was up something like that.
Okay.
Start again.
So yeah, so I was saying that this is we have a website. I shared that on in the chat, and it lists basically the core model, the exchange protocol, and it all the entities and properties that we came up with in our work. And for each entity, there are properties and examples. The way we came up with the list of entities, we have 7 entities at the moment. So research products, which could be of different kinds, literature, research data, software, and other products. We have persons, organizations, venues, data sources, grants, and topics. And both the entities and the properties for each single entity, the way we came up with this list is by exploring the data model of several open scholarly knowledge graphs. By analyzing the model, we tried to come up with something that was shared more or less across all of them. And so we had this kind of inclusion criteria. If a property is described by kind of a consensus, then it's viable to be put inside the model. And the same, this applies both for entities and for the properties of each entity. Next slide, please. Yeah, so this is, as I was saying, like these are in the rectangles, the 7 entities that we defined, and in the relation that they are that there exists between them. Next, please. So in terms of exchange, at the moment, as I was saying, we have like the option to have a all-inclusive zip file. I mean, like dumping everything in one shot. We gave can see Andre's slides. What? Sorry, I was checking in the chat. Can you see and hear me now? Yes.
I can see slides.
Okay. Okay. So we decided to give a bit of structure on how the zip file should be organized, so that in principle we could have just one parser that worked for everybody. And so like having subfolders and part files organized in a certain way. That's in the documentation. Next, please. And this is the API resolver. So we thought to have at least, as I was saying, having full-fledged APIs, it's a huge task. And for the moment, we are sticking to a ID resolver that works with a couple of methods. Basically, you can ask to the endpoint to list the schemes that the endpoint supports. So, for example, local identifiers, DOI, ORCID, Cordis ID, OpenAlex ID, and so on and so forth. And then by specifying the schema and the ID, as in the example, you can ask the SKG IF compliant representation of the, if any, of that item. So in this case, for example, you would ask the SKG IF metadata of the orchid, of this orchid here, of this person with this orchid here. Next, please. And recently, yeah, one back. Yeah, so recently we went through an extensive discussion on extensions because mostly we have, so like the spirit we were working with is to have, to find a common ground across all the initiatives, but then we have different applications that escape this kind of within project or communities that escape the landscape analysis that we did at the beginning. So we thought that we should put in place an extension mechanism, so to expand the set of properties and entities that are originally included by design in the SKGIF. And we intend to do that in this way. So through extensions, people, like a group of people, can define new properties or new entities, and establish the relations between the native entities and the new ones. Next, please. Extensions should address collective requirements. So we have, for example, within the GraspOS project, we have a need for indicators, because GraspOS is about responsible research assessment, and indicators is something that's not included at all in the original SKGIF specifications. So that would be a very well, very good case for extensions, but so extensions cannot be done just because an SKG escapes the standard specification and wants to share other things. So there should be at least collective consensus behind the application of extensions. So there should be a shared interest, and also there's an non-interference agreement with the core SKGIF specification. So the extension should not interfere, mostly disrupt the integrity and coherence of the metadata specification that has been drafted in the main specification. So, for example, you couldn't ask an extension to put information elsewhere as a shortcut just because you don't want to place it in the place that has been agreed within with the original specifications. For example, topics is an entity. You can't say that an extension cannot say that topics need to go in another place as a shortcut. Next, please. In terms of so towards the documentation of an extension, a case statement needs to be formulated for evaluation and endorsement by the working group, and documentation should be published online, and we will have another section on the documentation page listing all the supported extensions that we are considering in a given time, and every extension should follow the same structure for homogeneity. So listing the new, for example, new properties for the already defined entities, the new entities and their properties defined by the extensions, and the relationships that are insisting the new relationships that are present in the extended data model. Next, please. And in terms of adoption roadmap, so within OpenAir, we are currently mapping data towards the interoperability framework. Miriam is leading this task. And dataset and open citation should follow at some point this year. But yeah, it's something we don't have yet deadlines. Probably we will know these better once we have we reach a more stable version of the information model, because we are still tweaking things. And we also have a few extensions that are being discussed within the context of EU projects and communities, as I was saying, GraspOS and SciLake, and also in OS Trails. There has been a recent discussion on the interoperability framework. So I think that's the last slide from my side.
Okay, thank you. I think, Amir, you have your own slides, right?
Yes, that's correct.
Okay, then I'll stop sharing and then you can start. Thanks, Andrea, for that overview.
Sure. Okay, I can take over the screen.
Yeah, please. Yeah.
Yeah,
Yeah, I can see it.
Hi, everyone. So I'm going to present the concept of the Research Link Australia graph. This talk is more about the use cases of the scholarly knowledge graphs and given the context in Australia. Also, I should mention probably this talk should have been given by my friend and colleague, Dr. Ming-Fang Wu from RDC, but she's presenting another in another RDA session right now. So I'm kind of trying my best to kind of convey the message. This is less about the metadata as a construction of the graph. I almost want to pick what Andrea was talking about and just talk about some of the applications of this. So if like all of the engineering is around the scholarly knowledge graphs, when it comes to the application and use cases, this is an example of that kind of use cases. So Australia has a challenge, and that's based on the ranking from the OECD. We are not very good in translating research to business and innovation. So there's a lot of high quality publications, but there is less connections to the commercialization and patents. And that's something that the Australian government is keen to change. So if we want to look at the problem in a kind of a core, is that industry wants to know about the information related to innovation ideas, the R&D capability, research development capability, the researchers who are potentially are very good collaborators with businesses, the specialized skills and technologies available in Australia. At the same time, researchers want to know about the potential business partners, the commercialization opportunities, about where we can find the next collaborator for our next grant, or if we have a project that might need an industry partner to fund it, where do I find that industry partner? So closing the gap between these requirements is really what the use case here and what this project is about. Research Link Australia is a RDC initiative. That means this is actually a program and a platform that's been created by Australian Research Data Commons. And the idea or the vision is that it creates a new capability in Australia to enable discovery and share of information about the research collaboration. And that's specifically about the research and industry collaboration. So closing the gap between the business and academia. And in the next few slides, I'm talking about the earlier stage of the project, how about the conceptualization phase, about the MVP part that is happening as we speak these days, and also the plan for future developments. So the initiative started in late 2022, and there has been a round of consultation around the project that constitute on what are the stakeholders in this environment in Australia, what are the interests and requirements that they have, how do we prioritizing and identifying needs for each one of these stakeholders, how do we actually find out what needs to be developed first. So there has been a lot of consultation and co-design until 2023 or mid 2023 that then ARDC have started to developing a platform based on this. There has been a number of conversations about identifying what functionalities for a system like this actually provide the most value to the community. There are different stakeholders and there are different requirements. So there's a level of interest between the requirements and the stakeholders, or connections, if you like, between them. And then there are different requirements, has different dependency to different information sources. And not all information sources are equal. As Andre was talking about, getting the links between these things by itself is a challenge. A lot of information in this domain is public, but a lot of them are not. So finding out exactly what kind of capabilities are doable with the most impact, also at the same time take us to all the information needs to come underneath to actually make these graphs connected and capable enough to satisfy those requirements. The consultation process used the utility optimization model from economy type literature that it looks at the different complexity of factors and the different stakeholders and the representation of the factors for those stakeholders, and come up with a series of requirements that are the most impactful for the community. And the top range of those activities are who are the successful partnerships, what are the potential partners for both researchers and businesses, the research capabilities in Australia, including universities, research institutions, research centers, and also research facilities. And some of them are government-funded infrastructures sitting inside universities. And there are the second tier of requirements, like finding the facilitators, brokers, finding someone with a specific technical expertise, finding or identifying funds that actually enables those partnerships, and so forth. So again, I'm going back to that open science graph model, or the scholarly knowledge graph. So we actually looked into the concept of the SKG, and this is some of the conversations that there was a lot of collaboration in Australia and looking at different international models. So the SKG had a great influence in forming the model that at the end kind of enables the RLA platform and the graph underneath of this. So it has a research activities, including the grants, philanthropy, research funding, the industry-funded research projects. Then there are organizations that are government agencies, facilities, companies, research institutions, and then there are research products, which this term comes from the SKG. It looks at the publication, patent status, software, and instruments. And all of these can be connected to the researchers and domain experts and software developers. So to, if you like, bootstrap the project and make it more viable option for the MVP, ARDC has used the Australian National Peat Graph, which is created. This one was a project by Research Graph earlier, as it collects and continues to connect the persistent identifiers in Australia. This content basically provides a lot of information for a platform to have initial functionality. So the substantial number of ORCID records that connects to the Australian research ecosystem. There are the data sets, a substantial amount of publications and funded projects. There are lists of organizations that come from a Wikidata, Crossref, ABR is the Australian Business Registry, and ROAR. And the connection between these organizations, all the other elements, there has been a lot of natural language processing and to some level using the large language models to close the gaps, de-identify the entities, and do the entity resolution to identify who is who across the funded projects and collaboration networks. So there is an architecture in place for, or the abstract architecture, the image that I have here for the RLA system. So the graph connector layer resembles probably some of you have seen the research graph platforms in the past. This looks very similar. It basically reads the information from the internet gateways and repository file systems. It has the ETL system and microservices that construct the graphs. And then we have the discovery layer, which predominantly is an Elasticsearch platform with a front-end discovery system that actually enables access to the graph in a more kind of human usable interface. But also there are synthesized layer. These are designed to provide particular insights in a given domains. And the importance of this is that once you deal with such a large volume of information, you want to tailor that to the specific community. In this case, there has been the focus on the medical research and agriculture. And then there are insights related to those domains, which is specific. It talks about the collaboration in those fields. I will show you some of the demonstrator dashboards that are using this kind of data to just give you an idea of what kind of things that we expect to see in Australia down the track. So there are some demos that have been created earlier. They look at the Australian Research Council funded grants and look at the collaboration networks of that. So this, for example, this particular insight shows in the last 10 years, across all funded projects in Australia, 31% of them have funding or connection collaboration with the entity that was not a university. So that means it's kind of reaching to outside of the university space. And this is another one that looks at the same scenario, but looks at the health. So in the health space, the ratio of the connectivity was much higher, about 64%, and that actually speaks to the nature of the domain. So you can, in the kind of those demonstrator dashboard, you could look at the individual companies to see what they do and who do they collaborate with. The other concept, this is, by the way, this is the same kind of perspective, but just on the number of grants rather than the amount of funding. The other concept around this is that looking at, there is a new MVP portal that I think the launch is happening during these days. And that is provide a discovery interface into the RLA. That's the one that I was just talking about, is in architecture. And that provides specific requirements for researchers and for the business, potential business partners. Also, it provides an API interface that API enables software developers to harvest some of this information and use it as part of their infrastructure. One of the use cases in this slide is relates to a software developer who works on a business platform for a facilitator intermediary service. They are looking at the domain of agriculture, and they're looking for top researchers who also have expertise in the IoT, or in Internet of Things. So if they want to know, for example, how do I find a researcher that helps me with monitoring the soil, water, crops, and so forth, that's the sort of requirements that you will be able to address using this portal. On the other side, if you are a business point of view, you would also look for the same data set. But also the other example in the bottom of this page is a researcher who have developed new, or let's say hypothetically amazing technology in nanodiscs. And then the nanodisc technology can be used in a medical research. So the researcher wants to know who are the top 5 manufacturing firms in Australia in this space, and how do I contact them, and who will be the best partners in this space. So the discovery portal is a really human user interface to the graph that could be accessible. ARDC is currently, to my understanding, is that working with other partners in Australia to collect the data that are not available to the PEAT graph. That provides a gateway toward the information related to the contract research projects or projects that are not publicly, that are public, but the information is not structured in a way that are linked to the ORCID or other PEAT ecosystem. If you are interested in this project, that's the link to the project page and also the email contact for this. And to my knowledge, I'm happy to answer any question about the projects as much as I can. Thank you very much.
Thank you, Amir. That was really interesting, especially nice to see those dashboards. Yeah, then I think we'll go to Mike. Mike, I think you'll also be sharing your own slides.
Yeah, I'll share the slides from here.
Okay, perfect.
Oh, since I find my mouse, which has gone AWOL. Right. On this share screen. Yeah. Yeah. Okay. Hopefully,
yep, that works.
Seeing the thing here. So, hi everybody. My name is Mike Bennett. I work alongside Helena at DataSite, where I'm one of the application developers, and I'm working very heavily on the development of our PID graph, our expression of a scientific knowledge graph. So I'm going to give you a brief update on recent developments in the PID graph and the ongoing work that we are doing in this space. So in a nutshell, the DataSite PID graph is a collection of the scholarly resources that DataSite is aware of and the connections between them. So it's based, obviously, from the name PID graph, it's based around persistent identifiers. So all of the nodes in the graph are identified by a persistent identifier, and we then hold metadata and the vertices with rich connection data between these from various sources, including DataSite, Crossref, ORCID, RAW, and other places. Originally, the PID graph started as an output from the Freya project, and development has been ongoing. So currently, the development work is heavily based around Fair Call for EOS project as part of the wider EOS project. So it's a brief diagram showing some of the connections that you can find. So, you know, we're talking about this idea, as everyone has spoken about so far, of trying to connect people, places, and things, and expose the relationships between them inside the graph. So, as I mentioned, this is an ongoing work, an ongoing project, and you can see from this diagram here that, you know, in the sort of space of 4 years, the size of the graph and the number of connections increased dramatically. This is still going. In fact, since the latest diagram in 2023, we have added about another 50 million nodes to the graph and about another 100 million connections. So the main data that you can find inside the PID graph, the primary nodes are DOIs, so representing all forms of scholarly output, data sets, research articles, book chapters, anything you can assign a DOI to, instruments, samples, etc. So the data inside there is modeled with the DataSite metadata schema, and this includes when the data comes from outside of DataSite too. So we have crosswalks that make sure that when we're ingesting DOIs from other registration agencies, the data is all mapped so that it's a consistent format for every node. There are additional nodes for other types of PIDs, which are the kind of primary inputs into the PID graph. So currently that's ORCID identifiers for people involved and research organization registry identifiers for research organizations. Alongside this, the vertices of the graph have not just the triple of the relationship between the two PIDs, but also sort of rich metadata for the vertices. So things such as the provenance information, who is asserting this link between the PIDs, when was this link asserted, how many other sources of data do we have this assertion from? So, for example, if an article in the article DOI metadata, it says, I am citing this data set, then that's a link in one direction. But it's also possible that the data set may have in its own metadata, I have been cited by this research paper. And so that's the same link. It's the link between the two PIDs asserting the same relationship, but from the other direction. So you can find this in the vertices, in the vertex information. So you can see this, okay, there are multiple assertions that say that this link exists between these persistent identifiers. The PID graph data is surfaced in a variety of ways. So the primary ones we're using at the moment, we have the DataCite REST API. So this is a JSON formatted API containing DOI metadata for DataCite DOIs and some of the relationship data when it comes from the DOI metadata itself. So the use cases here is if you're ingesting individual records or small subsets of the graph, and you wish to make some basic API queries. We have what's called the event data API. This is essentially an API that exposes just the vertices of the graph. So if you're interested in looking at the relationships between persistent identifiers, the event data API, its core data model is, again, JSON, and it's essentially a triple. So you have the object-subject relationship kind of triad, telling you the actual relationship, the actual link between the persistent identifiers, and then the additional metadata that I mentioned in the previous slide, showing the provenance information, the time and date, etc. So this is designed if you're looking for discovering or ingesting links between persistent identifiers, for example, tracking citations of a research object, or looking at the research outputs of a person as identified by an ORCID identifier. We have the GraphQL API. So this is more towards the work for this session. So this is the graph-based view of DOI metadata and other nodes, and it contains some enhancements to the data in the form of sort of like predefined node types. So for every type that we have in the DataCite metadata schema for the type that a DOI can be, so dataset, article, instrument, book chapter, etc., then these exist as node types within the GraphQL API, so you can easily query the graph. You say, okay, I'm just interested in data sets. And this, obviously being graph-based, gives you the chance to make wider queries and explore these kind of two-hop or further connections, where you say, okay, I have, for example, a funder identifier, be that research organization registry or grid, or Crossref funder identifier or similar. Okay, I want to see all of the research outputs connected to this funder identifier, and all of the research outputs that have come downstream from those that have been cited by things produced. We have also an OAI PMH API. So this is, for those of you who know, OAI PMH is a standard protocol for harvesting data between systems. And this exposes the same sort of data, but in Dublin Core or DataCite XML formats. So if you're looking to take in data from the graph and you already have a system that handles OAI PMH, this is a good way to look at that. On top of this, we have data files. So as Andrea mentioned with the SKGIF, one of the outputs from that group is looking at defining formats for how do we exchange large quantities of data between knowledge graphs without the need to sort of make repeated API queries or large API queries. So to this end, we have a public data file, and this contains all of the DataCite DOI metadata records. And so this is useful if you want to bootstrap another system, another graph, take in all of the data to enhance your own local graph, or even extract a subset via analysis. And I'm currently working on a second data file which will contain all of the vertices in the graph. So if you're looking just to enhance your local graph with connections out to other persistent identifiers, but you don't necessarily need the metadata for those nodes, then this data file will give you an efficient way of saying, okay, tell me about relationships between persistent identifiers. And sorry. We also have a visual front end called DataSite Commons. So this is an interactive web-based front end that allows you to explore through the graph. So it contains detailed pages for DOIs, some summary pages with metadata for the other node types we support, and faceted searching, filtering, and analysis. So when you view a DOI page, you can see the related works. You can see force-directed graph that shows you the contributors and how they've contributed to the outputs based around that persistent identifier. So the public data file, as I mentioned, was launched earlier this year, and it contains a full data dump in JSON format, and it's available from data files portal. So we have the public data file for 2023. You can see a little thing there. So this is a portal which will eventually contain all of the different data files being made available as part of the PID graph service. Other ongoing work at the moment is to increase the number of links and vertices in the graph by ingesting from new data. So our event data harvesting service started as a partnership with Crossref, and this has recently been updated to make best use of the newer Crossref relationship service for bringing in DOI relationship data. And we have enhanced already some of the processing of link data this year. So in 2024 so far, we've added, it's actually more than 70 million. That's about 100 million new links between persistent identifiers. So this has involved a lot of underlying technical and infrastructure improvements. As we prepare as part of the FairCore for EOS project to start bringing in new sources of data into the graph. So currently the event data is based around assertions from Crossref, from ORCID, from DOI metadata submitted to DataSite, and a couple of other places. And what we're looking to do to make the graph wider and more useful and a fuller picture of the whole scholarly ecosystem is to bring in new sources of data. So I'm working with partners, including sort of ZB Math, and some of the climate people.
On a établi une convention entre l'OPGC et puis le LANTJ l'an dernier.
That wasn't just me, right? No, okay. To bring in new links into the graph. So we look to expand the utility of this and bring in more data to expand the graph. In order to do that, there's some improvements currently ongoing to the GraphQL service to support more varied query types to allow slightly richer querying. At the moment, you know, there's some parts of the graph data are difficult to query, so we look to modify the PID graph output to the GraphQL service to make this a little bit easier. We are currently working on bringing in support for RAID identifiers within the PID graph service. So I've been working with Sean from ARDC and Clifford from SURF on making sure that RAIDs, which will be DataSite DOIs when they're created, are all available inside the PID graph, and that they will exist as a node type in GraphQL, so you can easily query them. And perhaps of the most relevant to this session, enhancements to the data dump data file. So moving from JSON to JSON lines for slightly more efficient parsing and querying of the data, and alignment with their SKG-IF that Andrea presented before in terms of the layout, but also the format. So as the SKG-IF develops and reaches towards the sort of version 1 maturity, I'm attending the calls and looking at the way we can output all of the PID graph data in the SKG-IF format to allow for full interoperability with other knowledge graphs existing. So this is obviously an ongoing work as the SKGIF format develops. But the goal is that once it's reached a mature stage, we will look to provide all of the PID graph data in this format for interoperability. I'm also working on some tutorials and guides just to sort of show the best way of working with these files. So hopefully these will also be useful for SKGIF adopters. And there'll be some example scripts and some codes and command line tools such as JQ, just a few nice bits and pieces there to show you, including a sample file so that if you wish to investigate this and try some development against the PID graph and against the SKGIF format, there'll be a sample file you can download with 100,000 records or so, rather than having to download the whole, hundreds of millions of records just to test things around. Other ongoing development includes the PID links data file, as I mentioned, containing just the vertices. So that's currently under development, and I would expect towards the end of this quarter that will be available publicly. Some development on subsets of the graph for interested parties, so that again, if you wish to have the graph data, but you don't need all hundreds of millions of records, you just want something very specific. So we have, for example, some use cases here with national level CRIS providers who say, okay, I have already local data about research outputs from my country, but I wish to expand that with anything further known about these objects from the graph. Ongoing work with development of harvesting agents for bringing more links into the graph, so focusing on OAI PMH and specific APIs, but also the SKGIF format for bringing in links and data. And then downstreaming that of providing that data out into the PID graph services and outputs when it's available. So that was a whistle-stop overview of the current work ongoing with the DataCite PID graph. I hope that was informative. Thanks very much.
Yeah, thank you, Mike. Great overview. As I said at the start, if there are any questions, feel free to put them in the chat. We'll have time for some discussion at the end. I think, Paolo, you're next. Would you like me to share my screen again, or would you rather do it yourself?
As you wish. I mean, if you think it's faster to do it your side.
I mean, it's
good for me.
Yeah.
Okay, so let me share my screen. Can you see it?
Yeah, there we go. I see your email,
Okay.
I think, but yes, I see your screen.
So that's not probably the right thing to do, okay?
Maybe not, yeah, maybe not the one you wanted to share.
Yes. No, that's the other screen for sure. Wait a second. Let me try that again. Start to your side. Okay, that should do, right?
Yeah, that's it.
Okay. So quickly, just to introduce Anita's part. So when we started this work, of course, we had a few scenarios in mind. The idea came up from initially from some colleagues from Crossref, from Open Citation, from DataCite as well at that time, because we were all trying to nurture this kind of scenarios where you have applications that are that requires the aggregation of data, typically coming from very large collections like the SKGs that have been mentioned so far. For example, to build new SKGs, like in the first case, or in some cases, and it was foreseen by some colleagues in community domains, to enable federated search, so using common models, common understanding. So models and protocols here were the buzzwords. And in some cases also point-to-point, so how from an SKG can I resolve, for example, an object that is located in another SKG and vice versa. From this, we extended the notion of SKG, of course, not just to aggregations of metadata, but also to collections that were authoritative in a way, so there were kind of also repositories could be seen as SKGs, or registries like Crossref and DataCite that are actually giving, you know, the milestones and let's say the first place where to go to resolve an object. Okay, so all these can be seen as SKGs as long as they have objects with identifiers and references between them that can refer internally to the SKG itself or to some other SKGs out there. For example, pointing to an ORCID, pointing to an organization. So what we did initially was to group and gather a number of colleagues and communities that were interested to participate into this exercise. And we started looking at it from the SKG or individual SKG perspective, also from the models of SKG's perspective, for example, Serif, okay, or the DataCite schema itself. So it's not just DataCite, but all those collections matching the DataCite schema can, in a way, respond to the SKG basic requirements. We asked them to gather and start a discussion on which could be potentially the chances of interoperability, touching upon the most common properties and most common entities or relationships that they were providing, okay, to enable, let's say, this communication across SKGs. So the methodology was that of starting from real case SKGs to identify the common entities, which are treated by the individual SKGs, identify common naming for those, because in some cases, the very same entities were named in different ways, and then selecting the most common entities. So what we decided to do in the beginning was to focus on the entities that were, pragmatically speaking, dealt with by at least 5 or 6, I don't remember, SKGs. So that was the idea. So this means that we left out some of these common entities, of course. So these are the entities that we have today. So literature, resource data, resource software, and others. We stuck to some very generic definition that would actually meet the conditions of the graphs that were providing such entities. I'm not going through this now because it would take forever, but these are taken from RDA working groups or from common notions in the library world and so on. We also considered contextual entities around this. So this research product is somehow at the center of an SKG because it's, let's say, the common lingua franca, the thing that we would like to talk about, that we would like to discover, we would like to analyze, we would like to research, assess, and so on. And around it, we have these notions of authors, so researchers in general, organizations, journals, topics, grants, conferences, affiliations, and authorships. Note that affiliations here are seen as the connection between a product, an author, and an organization at the same time. So they're somehow an entity on their own, like a triple relationship. So we had to model it like this, and this is common for OpenAlex, for open citations, and so on. So to identify these kind of relationships. So that wasn't obvious at all. We had long discussions. And if you take a look at the model that we have defined, we have proposed a common understanding and the solution to this. So this means, as I mentioned before, that many other entities are in a sort of waiting list. As Andrea mentioned in the beginning, the approach that we are willing to adopt is an incremental one. So we will go over and over to revise the model and extend it because this is the way it was conceived since the beginning, trying to introduce new entities according to new use case scenarios that we may have. We especially care about community entities. So this is the case when you would like to model an SKG in the context of a specific domain where the entities that we have provided, for example, which are cross-domain somehow, are not enough to describe some of the properties or some of the, let's say, concepts also behind a specific universe. I don't know, the bones of a dinosaur or whatever. So it is critical, in fact, to enable the usage of this model in specific communities to facilitate the extensions and to include a methodology to extend the entities under a specific profile of a community and to make it part of the overall modeling that we have of the SKGs. so that when somebody like an alien comes to Earth and finds the SKG data model, can find what we believe is common, what we believe is core, but as well as other extensions that match conditions in specific disciplines or domains of interest in general. So it is crucial for us basically to collect use cases, to keep on analyzing different use cases, to understand how different models, how different protocols, in fact, satisfy conditions at the domain level or the cross domain level, in order to make the SKG a framework that can be a standard and that matches the needs that it is intended, in fact, to address. So I leave the floor to Anita because she will continue on this flow and trend. If you have questions, I'll be there at the end.
Yeah, thanks, Paolo. I think probably makes sense for you to continue sharing your screen because I think Anita has one slide. So
Okay.
Yes, I do. Thank you. So thanks so much, everyone, for dialing in. Yeah, building on what Paolo has said, and by the way, I'm Anita de Waard. I'm with Elsevier. I'm new to the group, but very interested. I've been typing some things in the chat because there's a lot of interest within scientific publishing for all of these SKGs, and to look at how can we better integrate this with science publishing. And in particular, the one question I get is, well, when I talk about this internally or with other publishers, they're saying, well, there's so many of these open science groups, who uses them? What are they used for? What formats are they in, etc. So as I joined the group, I was wondering if it might be interesting to do an internship project to support this work, where we would have a fieldwork study that aims to look at the current open science graphs and to check them and normalize a set of features such as the formats, domains, covered, standards, etc. And have a single overview that wouldn't go into the great depths that we see here, but that would be, for instance, easy to use for publishers or for others that want to join. And I was struck by your comment on aliens, Paolo. I think exactly, if we want to say, what are OSGs and what is possible currently today, that's what the goal would be. There's been an extensive summary already conducted by the leads, and actually I put a screenshot of the summary on the next slide. We don't need to look at it, but it's in the deck in case you want to look. And we think that the members of the OSG, but also the broader open science community, would be the audience for the final report, which we would like to share with the community broadly. As a second task, which could be done by the same person sequentially, or could be done by two people, we would be interested in a study of use cases. So use cases of the type actor goal requirement, also scenario reporting. There are different frameworks within which to do that. I worked earlier at an RDA group that was around search. It was a paradigms for data discovery group, and we wrote an article on use cases for data search that actually was quite successful and got quite a few citations. So we think that might be either, as I said, a separate project or a sequential project. After knowing which OSGs are around, could we possibly look at use cases and make an actor, as a reader, I want to trace a link, these kinds of things. So we'd be very interested if there's anyone in the audience who is interested in this work to reach out to us. We did get a tip to maybe look at the RDA Tiger teams, so that's something we're going to explore. But if there's anyone interested in working on this, we'd love to hear from you. And that's really all I have to say. The next slide, Paulo, is just a screenshot of your document. I don't know if you or someone else wants to say anything about that. I wasn't involved in developing it, but I don't know if you would want to say a few words about it.
Yes, well, I think Andrea mentioned something about it already, but the idea of this spreadsheet is to have on the one hand, on one side, the properties and the entities. So you see at the bottom in the tabs here, you have the different entities. For each of these, you open a worksheet where you find the properties. for the properties, you have a generic description of mandatory, recommended, optional, and occurrence. And on the right side, you have the different models or SKGs and how they map onto the specific property. So it's a sort of crosswalk sheet that we maintain and we keep on maintaining over time. So if any change is applied to the model, we try to reflect it here and have all the mappings and the crosswalks updated. There's a new one that is ongoing now, so we're going to have the schema.org as well, because that's another thing that we're trying to consider. And again, this is a crosswalk, so it's more conceptual. So there's nothing that resembles an exchange format. We started with JSON, but there are discussions on how to do it in other ways. So JSON LD is one option. Schema.org itself could be one option. So we're very open to have multiple ways of sharing these SKGs format, let's say, to include in the eligible models more than one model in order to, let's say, welcome or adjust to the concrete scenarios and real use case scenarios that we have. So again, as Anita said, we can expand on this, of course, and go beyond, also touching upon communities, as we mentioned.
Thank you. And there's already a comment in the chat from Alex Delipalta to say that maybe this is something for the Tiger team. So that would be great. That's it for me, Helena.
Okay, great. Thank you, Paolo and Anita, for the overview. Yeah, and great to see, Alex, that there may be some possibilities. This is really sort of the next thing we'd like to do with this group, to take this further. So it would be really great if we can find a way to get this started. If anyone else has any ideas how we can do some of the work or is interested in contributing, then yeah, please let us know as well. I see, Alex, you're appearing on camera. Would you like to add anything?
No, just to say hi, and yeah, Tiger can help you. We can definitely discuss to see how we can support you, and our team will reach out to discuss further.
Perfect. Yeah, that's a really great outcome of this session. Are there any other questions or comments or suggestions? I mean, feel free to unmute and share your thoughts.
I actually have a question for Paolo to kick things off, perhaps.
Okay, Anita can go first, and then I think I see Nick appearing, who can then go after Anita.
Sorry. Paolo, we recently had a chat that was instigated by Carol Goebel, who has something called Workflow Hub. And there are a number of publishers who are interested in including computational workflows, and we were saying it would be really great. I saw RO-Crate on your list, but I don't know if workflows are on that list as well, and also if, say, a number of publishers say it would be great to include workflows as an element here. How would we best go about doing that?
Okay. Hello, Nick. Good to see your background again.
Nice.
It's been a while. So yes, of course, it's one of the many things. And again, it is a matter of modeling, right? So we would like to include as under or as a subtype of one of the existing meta types that we have. So if you want to consider workflows, for example, as a sort of software, or if instead we would like to have a new top entity that describes this kind of objects. These are the questions that we should ask ourselves to keep on having a data model that is easy to understand, right? Because we cannot expand forever. We cannot take at the top level individual classes of objects because it would become terrible to maintain or to understand or to navigate. But of course, workflows are one of the main and key elements here in science, right? And they expand across different domains, and so they should be considered. They include many, so I'm not saying this is the way to go. Consider software a very generic category, so something that includes everything that is somehow executable. So it's different from some passive data that you're supposed to process. And in that sense, a workflow is something executable. But this is, again, philosophical, still important to be discussed before you go down to the ground and take a decision on the model side.
So I see some raised hands. So maybe we go to Nick first and then to some of the people that raised their hand.
Great, thanks. So Paolo, I was gonna mention the work we did a couple of years ago on EOSC Enhance, where we used fair sharing as kind of a registry to harvest metadata using bioschemas. But I just wanted to say maybe we could carry on some of that work in this group, because that's obviously based on schema.org. And also we have a more domain agnostic sister site of bioschemas called schemas.science. So we could look at kind of tying in some of this work. Maybe I could contact you. The other thing was practically, I was trying to see if I'm a member of this group on the new website, and I can't find where I see that.
Yeah, the website was migrated to a new version, so there's a lot of difficulties there. So we got lost. In our rights, in our ways to. I think things are being fixed incrementally. So you should write them. I cannot really help you. I'm sorry. I got lost myself in many ways.
Okay.
On the other option, on the other thing that you mentioned, yes. Again, as I was mentioning before, schema.org is taken into account in the moment. It could be a way to interpret and to export and exchange SKG data. We have to fully understand which are the consequences of this, right, in terms of understanding the reusability. But again, it applies very well on a domain-specific universe, and also the concept of extensions would come easy, and so on. So yes, it's under discussion.
Yeah, that's what I was thinking when in one of the earlier presentations where you're talking about adding more properties. It sounds like you would have a type and then build profiles on top of that. And the last question was the mappings that you do, like we did for EOSC Enhance, are they in MSCR or are they just a spreadsheet?
No, they're not in MSCR. MSCR is still not, let's say, at the level of being a production-ready service. So at the moment, we keep them in a crosswalk. So the MSCR, for all that don't know, for those who don't know, it's a service that allows definition and sharing of crosswalks, and it's under construction in the third core for EOS project. So it's not really fully ready to go, but we hope it will by the end of the project, because it's a very handy service and very helpful.
Yeah, exactly. And the other thing was that in one of the tasks in Fair Impact, which is kind of the sister project, we're doing mappings as a subject. So maybe I can point you to some of the stuff we're doing there for capturing
yes,
kind of data around.
Yeah.
Okay, thank you. Thanks for the presentation.
Thank you, Nick.
All right.
Thank you. I'm not sure who was first between Clément.
Yeah, I think Clément was first. And Nick, I was just checking the list, the member list. I don't think you're on it. So probably you still need to add yourself as a group member.
I'll do that now. Thank you.
Okay, thanks. Clément?
Yes, just to complete on Nick's point, and the fair mappings and all of that is being discussed in parallel in another RDA session right now. So this is to apologize because I missed a little bit maybe of this session today because I was running in parallel. So my question was for Paolo, with respect to the presentation of SKGs and all of the elements that you guys are aggregating in different kinds of SKGs. And my question was triggered by the slides where you mentioned we have these types of scientific objects now, these and these and these, and the slides was starting by semantic artifacts. I mean, this is an open question for triggering also a discussion or an exchange, but we are gathering in the context of the Ontoportal Alliance, and some of this work is done in Fair Impact, but not all of it. Multiple ontology and semantic artifact repositories that are hosting now more than around 2,000 semantic artifacts in an harmonized way. In different repositories, usually proposed by different scientific domain, from bioportal in biomedicine, agroportal in agri-food, and in the context of Fair Impacts, for example, we kick off Earth portal in the domain of earth sciences. And so I'm wondering how these component that we see as a federated. All of that is stored in triple stores, dispatches, and I'm wondering how they could join one day this kind of scientific knowledge graph federation.
Okay, so I think we should be careful not to confuse the way you exchange objects. So the fact that you can share a graph as a sort of semantic description of the universe, and the objects described by the graph itself. Okay, so let's not confuse these two levels. So I think the semantic artifacts that you've seen there is just a kind of entity that some suggested to have as a type or as a class of object in the graph. Okay, so that's different from saying that, of course, you can expose a graph using semantic artifacts. So these are two different levels. But yes, it is possible. The whole point here is that once you have a graph model, or let's say a data model that represents a graph that we all agree on, so that facilitates the exchange of data, is to decide which are the eligible formats, which means that the expectations from a user, a consumer of an SKG intended as an entity or a service that exchanges data with one of those models are the fact that you can expect this SKG to match at least one of those models, okay? And then I can build my consuming tools or scripts based on the assumption that if I access an SKG, I will surely have a chance to find the data according to one of those models or one of those APIs or one of, so they cannot be 100, they should be limited, but the point is to take a decision on that together. Okay, so because that's the thing, is the together thing that will make the difference at the end of the game. And of course, also maybe some funder, but in budget on it. But that's the other thing. Okay.
Maybe with an eye on the clock, Gerhard can ask the last question of the session.
Okay, thank you. I'll try to be brief here. I just wanted to make kind of related to what Clément was saying. But wanted to kind of make the case for semantic artifact that is on the waiting list to become to go off the waiting list in a way, because while the work with the portal is great, it's also still the fact, if you look at fair semantics, that the lack of common APIs to find semantic artifacts is an issue to fairness of semantic artifacts. So bringing them into the scientific knowledge graph and making different ways of storing and so on these more interoperable would be a big step. And I think that you get a lot of return on investment in a way, because if you have other data, then for the topic you need a taxonomy or ontology. And we often in our field, we have just started a working group on harmonized terminologies and semantics in material science in RDA. The issue is that we have a lack of artifacts, but also we have a lack of people that want to make fair data, finding the right artifacts to annotate their topic, their data. So in a way, it's like, if you then bring the semantic artifacts within your community at the same level, I think that would have a large benefit. So that's just yeah.
I fully support your statement. I mean, but this is true for all kinds of objects that are used by scientists in general, right? So, and that are useful for science in a way. The decision that we have to make is more on the, I know it is sad to say, but more on the pragmatic and practical side. So if we want to exchange data, how many sources will be able to exchange such data, right? So that's the point. So the critical mass behind it and the recipients of this model should be enough to justify the effort that we're going to make to include it. This is a different thing, however, because you have an RDA group. So the RDA group is working on this. We have an RDA group working on instruments, for example. So we could easily take these as extensions, right, and include them, hoping that if some of the graphs out there will offer this data, they will be able to do it through a common standard or agreed on model, because that's the idea, using that extension, but without expecting all the SKGs to have the extensions there, because that's the other thing. So it will be likely an extension more than part of the core. Okay.
Sure.
Again, everything is optional in the end. Mike pushed a lot for this, and he's right, I think, and we agree on this. But there is something that we can perceive as a common element in graphs, and there is something that we can perceive more as an extension, hoping to push other graphs to have it, right? So because the SKG intention in the end is also to push for the idea that if SKGs would include what we call an extension today, that we are going towards an extended model that is cross-disciplinary, that models the universe of science in a common way. So the SKG could be a connector between RDA groups that are working on specific representations of objects in specific domains, but also as a way to channel it to other communities and say, guys, if you include these objects in your SKGs, you're doing it according to a standard, and you're making the world a better place because we can exchange data.
I think with that, we're actually at the end of the session. So thanks so much to all the speakers and also all the participants. If you're not a member of the group yet and you're interested in the discussions, then please go to the RDA website and join the group. We'll have another meeting probably next month. I'll send a message through the group mailing list. It's no longer possible to send calendar invitations, so you will need to add it to your calendar yourself. But really great to see everyone here today. And yeah, please feel free to reach out to any of the co-chairs if there's something you want to discuss or can contribute to the upcoming work. So yeah, thank you very much. And I will close the session.
Thank you,
Thanks,
Lena.
everyone. Cheers.
Thank you.
Thank you very much.
Thanks, everybody.
Bye.
Thank you.